Hey, how you doing, superhumans? Welcome back to our new lecture. And in this lecture, we will be covering in detail about what are the various cases in which we do not send ICMP messages. And in these first two cases, I will be also telling you the reasons behind it, the core reasons, and then you will be getting a little bit of fun in reading the ICMP. Okay. Now, before telling you the first case, let's take an example. Let's take a very quick example. Let's say that this is the source and this is the receiver, and then this is router R1, this is router R2, this is router R3. Let me zoom it further for you. Okay. Now, before telling you further these things, I want to tell you this quick thing that let's say there is an IP packet and there is some data that we are sending inside this IP packet, and then there will be some header. I'm not writing the complete format. This is not the correct format. I'm just giving you an overview of the IP packet, what an IP packet looks like. I don't want to complicate things about the format of the IP packet. What I'm simply telling is that IP packet contains these two common things. So first will be data and second will be IP header, and this IP header is going to contain the source from which we have sent, the initial source from which we are sending this packet, and the final destination or the final receiver for which this packet is meant. Okay, now let's say that I have sent this packet P, which is containing, and I'll show this not as a packet. I'll write simply that this is the box, and inside this box this is IS and this is IR. So this packet P is meant for the receiver R and is sent by the sender S. So this packet first reaches this place, then R2, then R3. Now let's say that R3 has discarded it for some reason. Packet discarded here. Now we have already studied about the fact that whenever a packet is discarded by any node in between or even by the final destination, then we are going to report to the sender that I have discarded your packet, and that reporting is done using ICMP message, and that ICMP message is actually encapsulated inside an IP packet. Okay, now when I send this ICMP message inside the IP packet, so I will be writing this as this is an IP message, this is an ICMP message, this is an IP packet, although this is also an IP packet, but for the sake of your understanding I am writing it as ICMP because this packet is containing an ICMP message. So this router R3 is going to send the ICMP packet, the ICMP message encapsulated inside the IP packet meant for the sender S. So the who is sending it? R3, and to whom it is meant for? Sender S. Okay, now since this ICMP message is contained inside the IP packet, so when this IP packet is received by the is passing through the router R2, let's say that router R2 has also discarded the packet. So over here, technically, according to the protocol, as I have discussed before, that whenever an IP packet is discarded, then we report to the sender that I have discarded your packet. So who is the sender over here? So initially in this packet, I am going to, whenever I am identifying over here it like this, then in the first part of this IP packet, I am going to write the sender. The second part, I am going to write the receiver, who is the final destination. Better I should be writing the destination. Okay. So this is the sender, this is the receiver, meant for the sender S. It is an IP packet, so it is discarded by R2. Now R2 sends the packet to the R3, sends an ICMP message to R3 that I have discarded your packet. So over here, the sender is R2 and the receiver is R3 because this message was sent, this ICMP packet was sent by the router R3. So this router R2 is going to report to R3 only. Okay. Now let's say that this ICMP message contained inside the IP packet is discarded by R3 again. There can be a lot of reasons for the discarding of the packets. might be that there is a network congestion or might be due to some other error. Let's take a case that it again got discarded. So I'm showing it with another color, that R3 is discarding this packet as well. So it is going to send an ICMP message according to the protocol that I have told you, that whenever an IP packet is discarded, we send an ICMP message. So an ICMP message is sent to R2 that I have discarded your packet. Okay. And this ICMP message will be containing the final initial receiver, initial sender of the packet. So since it is sent by this ICMP message in the IP packet is sent by router R3. So router R3, and it is meant for R2. Okay. Now let's say that router R2 again discards this packet, and since it is of the form IP, it is an IP packet. So this router R2 should technically send an ICMP message back to R3 that I have discarded your packet. So ICMP message will contain that initial sender of the packet, since it is being sent by the router R2, and now the final receiver of this packet. Since this packet got discarded, because of which I am sending this ICMP message. So this packet's final destination was R2 and the initial sender was R3. So R2 technically should be telling the sender of this packet that I have discarded your packet. Who is the sender of this packet? R3. So it is going to send the IP packet ICMP message to R3 that I am discarding your packet. Let's say this packet is again discarded by R3 because of a lot of errors. Let's say network congestion in this particular case. Then again I'm showing it with green, yellow, black. Okay. Then again router R3 is going to tell, because it is a type of IP packet, tell R2 that I have discarded your packet. So it will be router R3 will be sending an ICMP message. Since it is sent by R3, this ICMP message is sent by R3. So here I am writing R3. It is sent to R2. The reason for that is router R3 has discarded. Oh, wait a minute. Router R3 has discarded. Just wait for a minute. I have made a little bit of a mistake over here. Okay. See over here, R2, and it was meant for R3. Now over here, when this packet got discarded, okay, we were correct. We were not wrong in this. When this ICMP packet, which is of the form IP packet, got discarded by the router R3, so it is going to send an ICMP message to the sender of this packet, to the sender of this IP packet that I am discarding your packet. So it is going to send the message to R2 because this packet's sender was R2. Initial sender of this packet was R2. So it is going to send the message to R2 and the message is sent by R3. So initial source of this ICMP message in black color is R3. Let's say that again this IP packet, when it reaches R2, it gets discarded because of network congestion. It is again going to technically send an ICMP message to R2 that I have discarded your packet. Now see over here, if this thing continues, it will go into an infinite loop. So the way to overcome this particular thing is that we should not be sending an ICMP message whenever we are for example, in this first case, when this router R3, it has this loop started from here only, because this is the source to which this packet ICMP message was meant for. In the first case only, when this router R2 receives this IP packet containing this ICMP message and it has discarded this ICMP message, so it won't be sending an ICMP message back to the router R3 that I have discarded your IP packet containing the ICMP message. This is the solution to this particular infinite loop, that we do not want to enter this infinite loop. This is the solution to that. That if an IP packet contains, I am writing the complete thing for it, contains an ICMP message, then if this IP packet, let's say this is IP1 packet, this IP1 packet is discarded, no ICMP message is generated. I hope that this thing is pretty much clear to you. Moving on further. The next, okay, one thing over here is that I want to tell you is there is a shortcoming. This is what we can say is shortcoming of ICMP. Even ICMP is not completely reliable. The reason for that is, what problem were we solving initially? That we should be able to tell the sender that we have discarded your packet. Now let's say that over here, this packet, when it got discarded, it was sent, an ICMP message was sent to the router R2, and router R2, because of some reason, discarded this ICMP message. Then we won't be sending any ICMP message further, because this is our rule that whenever an IP packet containing an ICMP message is discarded, we do not send an ICMP message back. So this ICMP message is discarded. Because of this, since no further ICMP messages are generated, because of our rule to overcome this infinite loop, the sender S is not going to know that his packet initially got discarded by the router R3. So this is a shortcoming of ICMP. Okay. This might be asked by your teacher in your interview or somewhere else. This is a really important point. And this is pretty conceptual as well. The second point is ICMP is not generated for a datagram that is not the first fragment. What I mean by this is simply that, let's say that this is the datagram that we want to send, and we have divided this datagram into a number of fragments. Before, this is the source. Before sending it to the receiver R, I'm dividing this datagram into a number of fragments, and whenever these fragments are going to pass through this is first fragment, second, third, fourth and fifth. There can be a lot of fragments. When this fragment 1 reaches R, and if it is discarded by the receiver R, then only I am going to send the ICMP message to the sender that I have discarded your first fragment. And for all the remaining fragments, even if they are not discarded, I am not going to send the message. The second point is, obviously, when they are not discarded, why would I send the message? What I want to say is that even if, let's say that first got discarded, an ICMP message is sent to the sender S. If the second one, this first one got discarded, second one is also discarded, then it is not going to send, the receiver R is not going to send the message to the sender S that I have discarded your second packet as well, because in any case, if the first fragment is discarded, which is coming in the form of a packet, if the first fragment is discarded, then the sender S should be sending the complete datagram again anyhow. Now the second case is, this was case 1, when fragment 1 was discarded and second was discarded, but the ICMP message was sent for the fragment 1 only. The reason for that is, in any case, the sender S has to send the complete datagram again, even if the remaining fragments are not discarded. The second case, this is also one of the shortcomings. In the second case, it will be the shortcoming of the ICMP protocol. 3, 2, 1. Let's say the first has not got discarded and the second gets discarded by the receiver R. Now the receiver R is not going to send the ICMP message to the sender S that I have discarded your packet. This is the rule, and this is actually the shortcoming of the ICMP protocol, that it only sends an ICMP message when the first fragment is discarded, and when any of the other fragments is discarded, it is not going to send the message. Although it was beneficial over here in this particular case that if we keep on sending the ICMP message for every following packet that is going to be discarded, if the packet 1 is discarded, and if we are going to send the ICMP message for all the remaining fragments that are discarded, then it is going to congest the network. But in the second case, if the fragment 1 is not discarded but fragment 2 is discarded, then the sender is not going to receive the message, and the sender is not going to know that I have to send the complete datagram again. This is the shortcoming of the ICMP protocol. The third thing is pretty much theoretical, that is not generated whenever a datagram is having a multicast address. You need to remember this. And the fourth thing is, whenever a datagram is having a special address of the form this or of the form this 127.0.0.0 or 0.0.0.0, then if the IP packet with these two addresses is discarded, then the node or any host is not going to send the ICMP message back to the sender S. I hope that this must be very much clear to you. Rewind and watch this lecture again because these are really conceptual points. Bye.